All right, hello, welcome to the Off by One security stream on this Friday. This session, we've got Anuj Soni. We're going to be talking about reverse engineering malware with Ghidra. A lot of people have been asking for Ghidra for some time now, especially since some of the competition out there is, of course, can get quite pricey. And Ghidra, being that it's an open source tool now, it has quite a lot of community dedication and extensions and such being created for it, which is fantastic, makes it accessible for everyone. I even, for a while there, when I didn't have the hex-raised decompiler, I would use the one of the ports from Ghidra. I think that Chris Eagle created in IDA Pro, which was really nice because the hex-raised decompiler can be quite expensive as well. But yeah, so I've known Anuj for quite some time now. He is a SANS instructor, certified instructor, and an author, and wrote a fantastic course called 710, which is, there's a course 610's been there for a while, which is on reverse engineering malware. This one's more on advanced reversing and specifically code analysis for the most part. Anything you want to say about the course real quick, like a quick synopsis of the course?
Yeah, no, I mean, I appreciate that, Steve. Welcome, everyone. Thanks for having me. Yeah, the course created it a few years ago. Definitely put a lot, I think probably over 4 years, I created the content because, had the full-time job and growing family. I think I had one kid when I started creating the course and I had 3 when I finished. So I did cheat a little bit. I had twins, but that's just a testament to kind of how long and hard I worked and how hard it was to work on the course. But yeah, definitely check out the description on sans.org. If you're interested, in particular, if you've taken 610, you're a perfect candidate for 710. But if you've been doing reverse engineering for a while, then you may be open to just jumping right into 710.
Yeah, I'll put the link up for that a little bit later while you're doing some demonstrations. But yeah, and for anyone out there who's ever written a course or a book or even a blog or some kind of research paper, you know how big of an undertaking it is. It's a ton of work. And you use Ghidra in your course. I use IDA Pro in my course, so it's good. I'm looking forward. I've used Ghidra here and there, but I used it like when it first came out, so there was probably a lot of stuff still in development. Like there was no debugging support. And there's a lot of other things like that I really needed and was used to that wasn't quite there. And I'm sure it's there now. So I look forward to seeing some stuff and learning a bit myself. What's your background, Anuj?
Yeah, so background, I mean, so I've been in cybersecurity for close to 20 years, getting close to 20 years, probably next year. And kind of started off working for the government, doing kind of more development related tasking, but it did involve some traditional forensics. Eventually transitioned to doing incident response, both for the government and then eventually commercial as well. And that's, of course, where I kind of happened to come upon malware on a somewhat frequent basis. And I always felt that during incident response, of course, we had a little bit of time to dig into it, to rip out IOCs, but it was just never enough time, right? Anyone who's done incident response knows that time is of the essence. And you don't have, a week to spend digging into one file. You have to learn as much as you can, as quickly as you can. And even if there's some functionality in there that may require, days of work, you oftentimes just don't have the time to dig in. So that's really when I decided I wanted to try and make that time. So as much as possible, I tried to define myself as the malware analyst as part of an IR team. But eventually, when given the opportunity, I just went 100% full-time into reverse engineering malware positions. And that's really where I've been for about 10 years now.
Okay, that's great. A lot of people ask me, and of course other people, kind of how do I get a job doing malware analysis or doing vulnerability research? And I always say it's one of those catch-22 type situations where they expect you to be pretty well versed in it to get the job, but to get that kind of job, you have to get experience from doing it. So a lot of us do that on our personal time. So like on that note, what would you think? What would you say is like one of the better kind of resources out there for free that you can pick up some of the basics and maybe intermediate even?
Yeah, I mean, to get started with the field, certainly, in order to learn malware analysis, you got to do malware analysis, right? And so anything that puts you in a position where you have a VM open, right? Of course, you want to do this sort of analysis in a protected environment or relatively safe environment, and actually start double clicking or executing content, understanding the artifacts of execution, what's happening on the network. So it could be as simple as finding a blog that kind of resonates with you, where they provide the hash, getting access to that sample and just doing that on your own as a starting point. There are some books, right? Books are generally cheaper than any course you'll find out there. And so, when it comes to malware analysis, the one book that I think even non-malware analysts have on their shelf or on their Kindle somewhere is the Practical Malware Analysis book, right? That red one with the alien. That still is, I think, the best malware analysis book. I mean, there are many others that are certainly good and have some things to offer. But what I like most about that book, that is like 10 years old now, is it's really laid out like a course. It starts off at the beginning. It lays down foundational concepts without spending too much time on them. I think it targets the skill of malware analysis very well. So while you could take a semester-long class on assembly, it talks about it for like, I don't know, 15 or 20 pages, because it tries to just give you what you need to know to get started with malware analysis. And at the end of every chapter, it's got exercises. So that's a really good one to kind of get started with. But really, it's just about whatever works for you to just start analyzing malware. Maybe it's watching a YouTube video. Maybe it's finding a blog. Maybe it's a book. Pick one of those, whatever resonates with you, and just start looking at files. And that's really how you're going to build this skill set.
Yeah, totally. Hands on the keyboard, absolutely, as quick as possible is definitely a recommended method. I guess that one question I had, and so sometimes people DM me questions in advance of one of these streams to kind of say, hey, do you mind asking this? Some people don't like, typing it on here, but if you do have questions, please do type them up. But one of those questions that was sent to me is kind of, and we can't get out of any webcast or stream anymore without talking about AI to some degree. But like when you look at the traditional pyramid, I guess I even saw it in your course where you've got automated malware analysis and then static analysis, behavioral, and then code analysis at the top, which being the most advanced, I guess you could say. With AI getting better or machine learning getting better and kind of where we're headed, and we've had automated sandboxes for a long time now to do malware analysis, and I know there's been pros and cons about those, but where do you see things going, and do you think that the need for malware analysts will shrink at all, or do you think it'll stay large and AI will just be an aid to that, or where do you see things going?
Yeah, I mean, I think that, the reverse engineering skill set, right? It's rare to find a company that has, teams and teams of reverse engineers. So already I would say the skill set is one that generally organizations, unless you're like a managed service provider or an AV vendor, you generally don't have many reverse engineers, right? Maybe you have just an incident responder with a reverse engineering skill set. So, already I think that the positions are somewhat limited when it comes to RE, but in terms of AI, I mean, I think that what AI has to offer, and I'm sure many of you have seen this, right? People have created plugins for it, whether it's Ghidra or other tools as well. That'll basically summarize what the functionality associated with some code actually does, right? And you can copy and paste assembly into ChatGPT, and it will try to give you an idea for what that code does. And that is, of course, a core component of malware analysis. But having done this for about 10 years now, I can tell you that despite any advances in sandbox technology or even the past year with AI, none of it replaces a human. I mean, certainly some of the menial tasks can be made faster, but you still need, when you're talking about a sophisticated threat and detailed investigations, you still need a human that actually understands this stuff to, at the very bare minimum, confirm what these automated tools are saying and really put together the story of what a sample or group of samples is capable of doing. So I see it as an asset instead of competition. I think it can help me do what I need to do in the long term and allow me to focus on really the most interesting aspects of malware analysis. Yeah, that's kind of my perspective on it. I don't see it as something that that should generate fear. I think it's something that if you have a real passion for this skill set, will allow you to actually dig even deeper because you don't have to worry about the boring stuff as much.
Yeah, for sure. I mean, one of the areas I found when I've done malware analysis to be a bit challenging sometimes, depending on how obfuscated it is and whatever other things are factoring in, is working with encryption routines. Have you tried like working with any machine learning or whatever to see if it can help out with disassembling that or make sense of it? I use it a lot for, I'll take something, I've said this before in the streams, I'll take something like if I'm interested in Microsoft Terminal Services and I see that there's decompression routines and decryption routines and deobfuscation routines. And then I see a call, like what I'll do a lot of times is search for a memcopy call to see how the size argument's being calculated. And when you're doing something complex like decryption or obfuscation or compression, it can be quite daunting to go in and try to do that by hand. So I've had some success with getting AI to help out with that and actually save me tons of time. Have you done that at all?
So in your case, you're using AI to understand the algorithm or to do something else?
My example was to like determine how the dynamically calculated size argument for memcopy is being done based on the pseudocode from a decompiler that has like, just complex code.
Yeah. So from a malware analysis perspective, when I'm like digging into an algorithm, my ultimate goal is, well, there's really two goals. One is to just, first of all, get at whatever it's hiding, right? Whatever it's decrypting or decoding, I want to understand what that underlying content is. And two might be to maybe create a YAR rule, right? Some sort of signature associated with that algorithm to, group that family of malware, or at least maybe that particular custom algorithm. And so in light of that goal, I generally, whenever possible, I try not to worry about the details of the actual algorithm. And so, sometimes that's just using a debugger to just allow it to do the dirty work for you. In other cases, something more sophisticated might be using a binary instrumentation framework like Frida. You could also use an emulation framework like Speakeasy or Killing. In fact, I can probably go over a Killing example here if we have time today. So, I mean, given those goals, AI outside of just understanding code, and you're right, if it's incredibly obfuscated, AI may not be able to help you, right? There might be some obfuscation you need to remove for it to really even provide any advantage at all. But those are approaches that generally work better for me, because ultimately I'm trying to get at the underlying content. And if I want to have an understanding of the algorithm, AI might play a role in that case. But in most cases, I'm trying to characterize the algorithm without having to worry about the individual operations, if that makes sense.
Yeah, for sure. Yeah, it'll keep getting back to, which is great. So let's go ahead and switch over to some demonstration now. That's what everybody comes here for the most part. They love to hear us talking, but they always want to see the demos, which I completely understand. That's why I created the channel. But every time I see you, I'm like, damn, this dude always got great hair and beard. Like I was gonna actually fix my hair today because I do it about maybe 1/3 of the time. But last night I cut my face because I was joking with my daughter, making her think I was shaving my head, which upset her. So I had to make it sound like I was shaving. So I was using the clippers on my face. Got a nice cut right here. So I was like, I'm not going to fix my hair today, but you always look fantastic.
Well, I think you look great. I appreciate it. So let's dig into kind of some sort of a demo here. So of course, the title of this stream was to perform some reverse engineering with Ghidra. Now, a couple caveats real quick, right? Because Ghidra can be a triggering topic for some. I'm not here. I know you did a stream with the gentleman from Binary Ninja. What was his name? Can't remember his name right now. But last week, last week you talked about Binary Ninja. This is not an apples to apples comparison. I am not a developer for Ghidra. I am a user of Ghidra, and I'm not here to sell anyone on Ghidra. Okay, if you like IDA, all the power to you. I used to be an IDA user, but about maybe 7-8 years ago is when I transitioned over to Ghidra. That's what the SANS courses that I co-author and author use. And that's really what I've been using for a while now. That's not to say that it's better than IDA. There are some things I think Ghidra is good at. Some things certainly IDA is better at. But from my perspective, when I create videos on YouTube for malware analysis, I just want to be able to use a tool that is more accessible. And while IDA certainly has made some ways in terms of providing kind of free versions of its software, Ghidra is open source. It's completely free. It's got a decompiler. It's got multiple architectures. It is the complete package from the perspective of accessibility. I get it that it doesn't surpass IDA in every way. The decompiler is not as good as IDA's decompiler. Even the graphical interface is not as good, as, in my opinion, as IDA's what IDA has to offer. So it is just another tool for performing the type of analysis I do, which is reverse engineering malware. So I just want to get some of those caveats out of the way.
And you were talking about the stream with Jordan Wines. I thought for some reason I had Jeff stuck in my head, but yeah, Jordan Wines from Binja. One of the things I liked about Binja was how clean it was. The interface is like beautiful vectoring and such. And I saw in the latest IDA update just like a week ago, they added really enhanced graphics and vectoring of the buttons and things like that, which is funny.
Yeah. This has none of that. Okay, so. So we'll put that all in a box, and then put this in the box of freely available software with a disassembler and decompiler. Because I get it, right? Those tools. I mean, I haven't used Binary Ninja very much. It's kind of been on my list to dig into it. But you're right, it is a beautiful tool, right? The interface is amazing, and I know they've put a lot of thought into like very small details in the interface, which is very impressive. So I hope to make some time to kind of get some more runtime with that tool. So what I've done here is I got my VM here, right? And I went ahead and launched Ghidra, of course, from the desktop, this red and white dragon. And now we're presented with basically the project window. So Ghidra has a very project-focused approach. I know both Binary Ninja and IDA have more recently, I think, kind of taken on this project-oriented approach. Ghidra had it from the beginning. And I'm going to do my best to catch myself when I keep comparing these tools, because that is not my intention. This isn't a fight, okay? I'm just trying to present you with my workflow when using Ghidra. So, but one thing it does have, of course, is this project view, which I like. So most malware analysis these days is multi-file, right? So there's not just this one .exe. That was what it was like 15 years ago. Now there's this .exe that decrypts shellcode in memory, that downloads some other next stage, and so on. And so, there are typically several components, which I like kind of all being in one project. So the first thing you have to do is actually create a project. So I'm going to go here and create a project. Now, you have two project types. You got the non-shared project and the shared project. Again, I know having a shared project, a kind of community kind of perspective on building or analyzing samples is popular even with those other tools. And so that is the shared project option. Of course, here today, we're just kind of me doing analysis. So I'm going to stick with the non-shared project. But if you work on a team, you want to explore the collaborative nature, definitely consider that.
Cool. And real quick, even though you're not showing any analysis right now, but just zooming in when you can is really helpful because some people are using all kinds of different. Yeah, perfect.
Yeah, there we go. Okay. All right. So now we just have to give it a name. So just call it off by one. Finish. And there we go. So we have the kind of project all set up. And now we have to start really dragging and dropping files to actually do the analysis. So I got a few files here. We'll see what we have time for. But the first one I'm going to use is this right here. And by the way, if you happen to identify what type of malware this is, it'll become pretty obvious at one point. But maybe that name is slightly triggering to you. Let me know in the comments. So I've drag and drop this file. It's now doing its initial import. Okay, so it's not doing the whole like processing and the decompilation yet. This is a very basic import. And I'll tell you now, Ghidra in this respect, when compared to some of those other tools, is definitely slower, right? So there's more time to make coffee here than there would be with some of these other capabilities. But once once it's actually analyzed, things do get slightly easier. So still loading this up. This is just like a summary window here. There's not much to talk about or really anything to see here. This isn't really actionable in any way. I mean, you can see some basics here like various property information, version information, but I generally just click through this and move on. So now it's imported. It has not been processed yet. To actually get to a point where I can see the disassembly and start processing it, you're going to double click on this file. And of course, the dragon comes at you. I really wish they would add some sort of vocals to that, maybe a growl. But once you load it up here, it's going to ask you if you want to analyze it. Okay, so again, this doesn't happen by default. Generally, I click yes. The only case where I click no is if I'm looking at shellcode, because sometimes its auto analysis on shellcode kind of gets a little funky. So I usually click yes when I'm looking at a .exe, .dll. And I'm going to say up front also that I primarily analyze Windows malware. And although I think have a Linux sample that we might spend a few minutes on, that is kind of generally my background. So that's kind of what I default to here. But understand that Ghidra is very, multi-architecture, multi-platform. And so it could certainly analyze all sorts of file types. Now, before you actually kick off the analysis, and I will zoom in here a little bit, these are all the analysis options. And you can see most of them are checked with the exception of some of this red text. This is prototype stuff. And if you click on one of these, it'll provide a description of what it does. But here today, we're really just going to stick with the defaults. The one thing I will mention, there's one very important option here that is not text. You'll see it says Windows PE x86 propagate external parameters. And as you can see here in the description on the top right, basically this will provide some more information in the comments around arguments being passed to functions. That, of course, is helpful, whether you're reverse engineering for exploit dev or malware analysis. Now, it does say x86, so this is specific to 32-bit samples. It does not have this ability with x64, which is a shortcoming, but that is what it is. So since this is a 32-bit sample, I am going to go ahead and click on that and then press analyze here at the bottom. And then I'll maximize my screen here. And what you see on the bottom right is that it is now kind of starting its processing, right? So you could proceed to start analysis, although generally I would advise that you wait because very important things that could be revealed to you. For example, IDA has flirt, Ghidra has FID, its function ID feature. It's also going to be applying that process. So if there are any embedded library code here that it can identify, then you're going to want to let that complete so you don't start digging into code that you think is custom, but it's just library code. You can see this completed pretty quickly, but that can take some time. Did I see a question come up here? Can you cover SEH manipulation as a method for deterring analysis? Additionally, some of your favorite ways to view the imports. So I will get into kind of some of the imports view, some of the basic pivots into code. Probably don't have time to get into SEH manipulation, and I'd have to find a good sample for that. This one definitely doesn't do that. But that is a topic that is worth covering. Maybe we'll do that on a future stream or something like that.
Yeah, awesome. Another quick question, just since we're just getting started around customization of the screen. Like, can you make it look nicer, and do you have much control over that, or are you pretty much stuck with what it is?
I mean, you can do like the dark mode. So dark mode used to be built in, and I think they had some graphical issues and they removed it. I don't think it's here anymore. Although I have seen some third-party kind of plugins to make it to do dark mode. But these are the options that you can kind of mess around with. I mean, the bottom line is you can certainly change colors and fonts and sizes. You can move windows around, but you can't do anything drastic. So I understand that to those who have not seen Ghidra before, this might be a little bit jarring, but largely you are kind of working with what you're seeing here. And there's no doubt it does take some getting used to. Okay. And on that note, I could, one thing I'll probably do here, since some of these fonts. So the listing display, which is really where this disassembly is shown, right? That's like the main view that, of course, you spend a lot of time with. You could change the font size here. So I'm just going to make it a little bit bigger, but I will continue to zoom in as well, just to make sure that we all can see what we need to see here. So just an overview of what we're looking at here. This, of course, in the center, as I just mentioned, right? This is the listing view. This is where you get the disassembly. On the top left here, you have the program trees. So you're essentially looking at the headers and the sections that comprise a Windows executable. In the middle here, on the left, you got the symbol tree. So as you can see here, you can get access to function names, imports, exports. This is not the cleanest way to access all of that, because as you can tell, once I start like expanding some of this, it can get a little crazy pretty quickly. So I'll show you some other views to access some of this information. On the bottom left, we have the data type manager. So this is where you'll find a lot of the structures that you might find helpful, things defined by Visual Studio. You can create your own structures down here, by like right-clicking, going to new, and then, creating a structure right here. Ghidra does have, and maybe these other tools do too, but ability to kind of automatically try and create a structure for you, which can be kind of nice. I'll talk about some of the cons of that, but this is where you can manually create a structure if you need to. On the right-hand side here, of course, we have the decompiler output. And, we're just basically at the entry point here for this DLL. But on the left-hand side, if I start highlighting things, right, it'll highlight those accordingly on the right-hand side. It does a pretty good job of staying in sync. As I kind of scroll around somewhere else and click, you'll see it updates on the right-hand side. Sometimes you do have to kind of remind it. I find that if I highlight it, then it'll definitely kind of refresh on the right-hand side. Although sometimes, just based on clicking, it doesn't always move. So potentially some room for improvement there. But generally speaking, I'd say 90% of the time it works as expected. So that's really just the basics of what we're looking at here. At the bottom, we have a console of scripting output. I'll talk more about scripting here in a little bit. So I'm just going to close this for now. So somebody asked about imports, right? Because, of course, when you're analyzing malware, you generally don't start with this, right? I wouldn't take a sample that I didn't know anything about and throw it into Ghidra. Normally, I would do some static file analysis, learning about the file without executing it, maybe looking at strings, imports, for example. I would do some behavioral analysis as well, actually executing it to understand, the impact to the file system, to the registry, to the network. And eventually, I would kind of arrive here. But when you were performing code analysis, you definitely want to have some pivots, right? Some ways to get to parts of the code that might be interesting. Although you could just begin at the beginning, that is definitely the hard way. And I would exhaust kind of other approaches before I just went to the entry point and started kind of just looking linearly at all the code. So on the topic of imports, right, you saw imports here on the left-hand side in the symbol tree. Another way to access imports, which is what I normally do, is I'll go to Window. And as you can see here, Window provides access to many of the different features of Ghidra. And, by the way, as you look at all of these, I won't have time to go over each and every one of them, but the built-in help menu in Ghidra is quite good. Like, you can basically hover over any of these, and hopefully it doesn't make a fool out of me. But if I hover over, let's say, console, and I hit F1, F1 is basically how you would access the help menu. But if you are like hovering over something, it'll actually go to that part of the help menu, which is quite helpful. So you'll see it brought us to the console, and you can read about the console here. Okay, so that's how you would kind of get more information on Ghidra as you are actually trying to use it and learn about its capabilities. But let me go ahead and choose the symbol references here. Okay, so symbol references are the way I would generally go ahead and get at the imports. Now, symbols are more broad than just imports, right? So as I kind of scroll up and down here, you'll see that there's other references to other labels, whether it's a function name, or some other kind of value that it's identified based on some of the plugins, which I'll talk about in a minute. But if I want to focus on imports, I'll generally use this button right here, right, which allows me to filter. And typically, to start off with at least, right, just to focus on imports, I'll deactivate most of these on the top except for imported. And under symbol types, I'll go ahead and uncheck most of these except for function labels. And then press OK. So now I got kind of a smaller list here, a bit more manageable. And if I were, for example, to sort by name, it sorts just the imports basically by name or the functions by name. And this is a bit more digestible. By the way, you might see right here, there is this is actually an export task start. So just in case nobody's guessed the type of malware yet, that might be another hint if you've recognized that export name. All right. So based on having a list of the imports, right, a malware analyst will typically try to find ones that are interesting and maybe dig into that in the code. So for example, I mean, there's lots to dig into here, right? You'll see references to some crypto-related API calls, create process, that could be interesting. Create mutex, right? Maybe you're familiar with this call. This is often used by malware to check and see if a particular mutex is currently being used. And if it is, maybe it means that this machine is already infected. So when I click on an import on the left-hand side, right, an API name, on the right-hand side, it populates with the references to that import. And what I generally focus on first, you'll see this ref type column here, is the call, right? So I want to find where these APIs are actually being called. So if I go ahead and click here, there's a call. I have to actually minimize this window or, use a bigger screen. I'm trying not to get the resolution too high here to make it manageable on your screens. But in the background here, it has actually gone to that call to create mutex. And you'll see part of it's kind of cut off, and that's in part because I increased the font size. If I want to change these column sizes so I can see things, there we go. Now the width is a bit more manageable. I just pressed this button right here, edit the listing fields.
That is an odd view to move the columns around.
Yeah, this, right? It like takes
that is weird.
So this is my call to create mutex, right? And if I go ahead and highlight it, you'll see it highlights it on the right-hand side here as well. And you'll see kind of a reference to the actual mutex it uses, the name, based on this sprintf command here. And there is a reference to a string, a pointer to a string right here, right? So if I were to like double click on this, it will allow me to actually go there. And this, for example, is the mutex that it's basically checking for, okay? So that is considered oftentimes an IOC if it is unique. And in this case, if you Googled this, you would find it related to certain types of, or certain type of malware, a certain malware very specifically. Did anyone guess it yet, by the way? I'm thinking not.
Take a quick look here. No, it doesn't look like it. There's lots of questions coming up. When you get a chance, that question, someone's asking the current state of detecting the ISA from raw binary sequences. Says they're doing a paper on that. If you get to a part where that makes sense to talk about it.
What is the ISA? I'm not familiar with that term. The ISA from raw binary sequences. I may need to be educated on what that is. So I guess the answer is detecting ISA from raw binary sequences. Let me know what that is, William. Maybe I think about it differently. I'm just not familiar with that term. I could try to answer that.
What the instruction set architecture?
Oh, is that what he's referring to?
I think so.
Okay. I mean, it doesn't. So if I feed it like shellcode, for example, it's not going to know what it is. You're going to have to tell it what it is. So if that's what you're getting at, right? If I just feed it shellcode, it's not going to know what architecture and compiler it is and all this stuff. Those are all options you have to manually choose and figure out based on other analysis.
Yeah, I mean, I would imagine that obviously each compiler, each assembler might choose different ways of doing something with the machine code. So maybe there's some signatures it can look for, but I don't know much about it.
Yeah, I mean, there's some tools that will, outside of Ghidra. Ghidra, to my knowledge, doesn't. But there are some tools, of course, that will fingerprint on those characteristics. But I've never seen Ghidra do it, at least. And again, keep in mind, right? I'm not a developer of Ghidra. I use it, so maybe it has features I'm not aware of. If you've used it before and know about it, feel free to comment. Would love to hear about it. Okay, so we've kind of, this is just a real basic pivot, right? Again, the reason I'm covering this is when I use Ghidra, I'm always pivoting, right? Generally, at least that's what I'll do first. Eventually, I'll get to maybe just literally looking at the entry point and seeing what happens in chronological order. But generally, these are common pivots, and this is how you would use an import, for example, in the import address table, the list of dependencies, in order to actually arrive at a particular call of interest. Other pivots you might use, certainly exports, right? Maybe you want to like look at the actual exported function. So if I go to the left here in the symbol tree, right, dealing with the exports on this left-hand side is pretty manageable. So task start is an interesting one. And if I go over here, right, I can start to understand, what is happening from this export. One feature I will often use is the function call tree. So if I go to Window, I will choose function call trees here. And what this will basically do is on the bottom, let me zoom out here, it'll basically provide some information on the left and right of incoming and outgoing calls. So this is a nice way to just kind of get the lay of the land in terms of functions that are being called by the function where you currently reside. And my mouse is being a little unresponsive here. Here we go. So, if I go down here, I can see calls to like create thread, which might be interesting. There's a lot of unnamed functions here, but as I expand them, you'll see they could possibly be doing some interesting things like create file, read file, and then there's crypt gen random, right? And so, if you haven't gotten a hint just yet, and maybe some more information is necessary, but this is a ransomware sample. I won't tell you which one just yet, although it will become, like I said, very obvious very soon. But ransomware often is responsible for reading files, encrypting them, and writing them. And the crypto API, the Microsoft crypto API is sometimes used, and that appears to be at least playing a role in this particular execution here, in the sample. Okay, so that's how you can kind of course, pivot by export now, and then use function call trees to better understand calls that lead to the function. Of course, in this case, we're just at the export, and calls that are being made from this particular function. You might also pivot by strings, right? So strings is another one. So let me go ahead and just close the function call trees for now, actually. If I go back to Window here, I can choose define strings. And this will give me on the left-hand side here, all of the defined strings in the sample. And you'll see a lot of them are associated with the import address table, which is pretty customary. I certainly would go to the imports more for that information. Although there might be references to APIs that perhaps are resolved at runtime, right? Ones that are not included in the import address table, so those could be interesting. But as I scroll down here, and this is where it becomes incredibly obvious what ransomware this is, start to see some strings of interest, right? There's references to files with some odd extensions, and references to like reg commands, maybe to configure persistence perhaps, and registry paths. And of course, you see references to wanted decryptor here, right? So as you could probably guess, this is a sample, a WannaCry sample. And a WannaCry, by the way, if you haven't done much malware analysis before, is just a beautiful sample to start off with. I mean, it continues to be the one I usually use to introduce Ghidra or just introduce malware analysis, because for one, it is not, much of it is not heavily obfuscated. And of course, obfuscation is where, as a reverse engineer, I spend a lot of my time. But initially, when you're trying to get your feet wet with malware analysis, I would kind of put obfuscation to step 2. Step 1 is just kind of getting familiar with the process and with the characteristics. And I think WannaCry has a lot to learn, or a lot to kind of provide from a learning perspective. It's also multi-file, right, which is multi-stage, which is what most malware is these days. It does include encryption, right? In fact, actually, this DLL we're looking at is decrypted in memory. So when you do get to learning about encryption in malware, right, it also provides some useful information there. It spreads across the network. It impacts services and other registry keys. So it's got really a little bit of everything, which is quite nice. So this is why I'm using WannaCry here today, because I think it continues to be a really good learning sample. And not just an old man who is reminiscing about the old days. So pivoting based on strings, right? So if I go ahead and we see this wantedDecryptor.exe link here, right? If I click on it, it populates on the left-hand side with the actual location where that string resides. Now, we often want to see how that string is actually being used, right? It's interesting to see the string, but we could have gotten that from even just running strings against the sample. When I'm doing code analysis, the reason I'm pivoting from strings is I want to see the context of that string, how it's actually being used. And so there are a couple ways to see references. So first, you'll notice that there's a reference to, or literally the text xref here. And what it's showing you is the function and then the actual virtual address, which is located in that function where this string is referenced. So I could just double click here in order to get to the reference. Another way I could do it is I could right click here and then go to, let me go ahead and hide this StreamYard screen actually. There we go. Whoa. There we go. If I right click here and then go to references at the very bottom, right? And let me zoom in here. You'll see this is where it gives me the ability, right? I went to references and then you can click on like show references to, and there is of course a keyboard shortcut, which is the Control-Shift-F. There it is. So if I click on that, right, this will also give me a list of references. So these are all just different ways to get to the same thing. You will see a push instruction here. If I click on that, it'll take me to the push instruction in the background. And of course, now I can see the context, right? Notice there's a call here to sprint F. And then there are actually several references to this, I think. And one of them eventually will execute decryptor.exe, which is of course, the decryptor associated with WannaCry. So this is basically pivoting by strings, right? Which is yet another way to kind of get to code of interest within Ghidra. Any questions so far, Steve? Maybe I missed, because I know I've been talking for a while.
Nope, nothing new.
Okay, so let's continue talking about pivots, right? Because this is at least how I perform code analysis when using Ghidra. So we talked about imports, we talked about exports, we talked about using defined strings. Another approach is to maybe take advantage of some plugins, right? Now, generally, I don't talk a whole lot about plugins. I think that plugins can be helpful, developing them can be great, and I know like IDA, for example, has a really healthy kind of ecosystem around plugins. I tend not to rely on too many of them, just because if I start relying on them too much and they stop being supported, or if I'm teaching students and I keep recommending plugins that stop being supported, that's not a good position to be in. But there is one plugin that I continue to rely upon, and I'm sure many of you, even IDA folks, have heard of this because it originally was an IDA plugin, and that is FindCrypt. So FindCrypt is a very well-known plugin that was ported over to Ghidra for identifying information associated with crypto, right? Like, for example, not symbolic constants, crypto constants, as well as other values that are used in various algorithms. So you may not have noticed this because I didn't explicitly call it out. But if I were to go up to analysis here and choose auto analyze, this brings up the same screen I had earlier when I kicked off my initial analysis. And one item here that was automatically checked was FindCrypt. Okay, so I've already installed this plugin. It automatically runs against all samples that I process within Ghidra. And really, this is just, it's just a JSON file, I think, that literally has, strings and byte sequences associated with algorithms. So you can modify it as you see fit and just restart Ghidra, and it will go ahead and load whatever you choose to add to it. But this is certainly helpful in identifying implementations of crypto algorithms. And if you want to take a look at the output of what FindCrypt actually identifies, you would go to labels here on the left-hand side, or at least this is one way to get to it. And you would go to C, because generally FindCrypt will, every time it finds something of interest, it'll label it with a crypt underscore something. And what you'll see here is it has found references to, for example, components of the AES algorithm. Okay, so AES involves substitutions and permutations. It involves a substitution box. And so what you can see here is it believes it has found references to those actual boxes, right, which are public values. Now, one little detail I'll mention to explain some of these other labels here is that when you learn about AES, you might learn that there is an optimization that involves the use of what are called T-tables. And those T-tables, if they are used, if that optimization is taken advantage of, you basically have these massive tables that are embedded in the actual program. And WannaCry does, in fact, use AES. And that's why we see references to these T, D, and TE tables. Now, you'll notice some of these are black and some are blue. The blue means that there are references to these tables somewhere in the code. The TD, these are T-tables associated with decryption. TE are T-tables associated with encryption. So with that in mind, you might guess why these ones are black, but these ones are blue, right? Because this is WannaCry is actually the component that encrypts files on disk. So although it has the D tables used for decryption, it doesn't actually use them because it's not decrypting anything. The decryptor would use those. This is encrypting files, so it only has references to these TE tables, the 4 of them. So this is another way to kind of pivot into interesting parts of the code, because if I wanted to understand not only what algorithm is being used in this ransomware sample, but where that algorithm is being used, what function is performing the encryption, this would certainly be a really good starting point. So I just clicked on TE0, it brought me here, and now I see it's got multiple references that I could, start clicking on here, and it'll take me to various parts of the code that actually reference these T-tables. So this is another kind of helpful way to start pivoting into the code. Now, trying to think here. Okay, yeah, a couple other things I wanted to mention about the code. We've been looking at the listing display like this. Ghidra does have a graph view, although I'll tell you up front, it does leave you wanting just a little bit more. But let me show it to you. If we go to Window and I go to Function Graph, this is where you can access the graph view. Just brace yourself here. So it's not the best function to choose, but this is what it looks like. The lines are a little bit thin, and I think you can make those thicker. But it is. I'll be the first to tell you, it's not as nice as some of the graph view of Binary Ninja or certainly IDA. Okay, so but if you're curious where that was, this is where it is. On the note of kind of graphical representations of functions, if I go back to Window and choose Function Call Graph, okay, this will just give you kind of a bird's eye view of what functions call what functions and where you are and what functions are called from there. Okay, so that's just kind of another view. Again, not particularly helpful for this random function I jumped to, but that's how you would kind of explore that particular perspective. So I tend to default to kind of using this text view and just using the visual cues with the arrows. Sometimes I'll use that graph view, but again, it's not my favorite way to look at samples.
Do you find yourself staying in disassembly more than decompilation, looking at the pseudocode?
I do both. I mean, as I mentioned earlier, and as I think a lot of people are aware of, anyone who's tried Ghidra, the decompilation in Ghidra is what I would term okay. So it's not the best. So I usually go back and forth. There are definitely some cases where the decompiler output is more confusing to me than the assembly. So I will usually, assuming I have a wide enough screen, I will keep them both open, kind of like this, and kind of go back and forth. But I try to take advantage, of course, of the decompiler whenever I can, because when speed is of the essence. But there are just some cases where it's decompilation output. I know I would spend more time understanding that than just going straight to the assembly. All right. Let's see. What else can I talk about here? Oh, let's talk a little bit about scripting. So Ghidra comes out of the box. It implements, it does have APIs, but Python, which is what a lot of people use. I mean, there is a Java API, but people are mostly interested in wanting to know how to use Python. And unfortunately, out of the box, it comes with Jython, right? Which if you just grew up in your mouth a little bit, I understand. It is unfortunate, right? So that's like Python 2.7. I think it's like locked there forever. But thankfully, right, the glorious, amazingly intelligent people at Mandiant and the Flare team have come up with quite a few tools for Ghidra, which have made life a lot easier. And one of those is Ghidrathon. And I think do I have the page up? So Ghidrathon is basically a way to use Python 3 within Ghidra, and it essentially allows you to use whatever version of Python you have installed on your system. It gives you access to all of the modules that you have installed, and really opens up the world to making Ghidra usable from a scripting perspective. Okay, now still there are some other downsides I'll get into here in a moment, but Ghidrathon is amazing. So if you go to GitHub, you'll find out all the information how to actually install it. That is what I have installed here. And to access the interpreter, right, you can go to Window and Ghidrathon here. Now, again, you have to follow the install steps. Otherwise, this won't show anything of value. It'll just have the default Python interpreter, which is 2.7. Okay, but this is how you would access the actual interpreter here. And, this is where you could start kind of testing commands. If you want to learn about the API, you can go to Help and then Ghidra API Help. And this will go ahead and extract and then show you a web page that provides you with API information. Now, again, it's the Java API is basically the same as the Python API in terms of the actual methods you can use. So you can still, even though we're using Ghidrathon, use the API documentation largely. There are some caveats to it that are well documented on the Ghidrathon page, but generally speaking, this documentation is really good. Okay, so if, for example, just it's a basic method here: get first function. Okay, this will like, that didn't work. Get first, let me try. Get first instruction. Oof, not making me look good, Ghidra. Not making yourself look good. Yeah, that's still not working. Get first, let me see here. So if we do current equals current program, all right. So let's choose something else. So this is where, so there's really two, I won't get into all the details. There's like the flat API and the program API. Flat API is streamlined, program API is more robust. This is the program API. And again, we can basically access whatever the Ghidra API indicates. The problem is, and this is what you were just seeing, is because this is a fairly new version of Ghidra, and I installed Ghidra like 3 days ago, so still need to do a little testing clearly. But the way you access some of these methods is not the way that the Ghidra documentation will say. Like you might have noticed, I use this current program method. This is specific to Ghidrathon. If you were just using the default Python 2.7 Jython, you could just do current program dot any of these methods and you would access them. But in this case, you kind of have to call this method first, which provides you access to the current program. So it is a little different. There's takes some getting used to, but you could, let's try just get executable MD5. So current dot get executable MD5, right? This provides the MD5 of the executable. But what I was trying to access first and what wasn't working for some reason was the flat API. So I'll have to take a look at that.
If you zoom in a little bit there too, it's kind of hard to see.
Oh, Thanks. Yeah. Apologies. So what I just did is use the program API, which is the more robust API. Although the downside of using the program API is it is not guaranteed to maintain consistency across versions, but the flat API is. But so basically use the current program API when you need to, because it is more robust, but use it at your own risk. The flat API, which is what the documentation showed when I just had it up in my browser, that is the kind of the recommended, those are the recommended API methods to kind of use. Okay.
Question coming in. Yeah, you saw that, right? For debugging with Ghidra.
Yeah. So I mean, my honest answer, right? This is my answer is I would not recommend it, but that doesn't mean it's you shouldn't explore it. I tried to get the debugger working maybe 3 months ago, and it was just not happening. And honestly, I gave up. So for debugging, I always have used x64 debug, well, at least for like the past 5 to 7 years. Before that, it was Ali debug, and that's what I continue to use for Windows malware analysis. So I know improvements have been made to the Ghidra debugger. But I don't know a single person who actually uses it on a regular basis. That's not to say you can't use it, but that's just kind of been my experience with it so far. But it was clearly not intuitive, at least for me to use. And so I decided to chalk it up for another day. All right. So later on, I'll find why that was not working, get first instruction. But this is how you would access kind of the interpreter. Now, the script manager for Ghidra, if I go to Window and then Script Manager here, this is how you access, this is the primary interface for scripting within Ghidra. Okay. And it actually kind of, and this is, again, has some caveats, but it comes with, as you can see here, 300 or so, some of these are mine, but 300 or so scripts, basically, that it comes out of the box with, which is really impressive. Now, you'll be impressed for a moment, and then you'll start looking through the scripts and realize most of them end with .java. Okay, so most of these are written in Java. There are some that are written in Python, but remember that out of the box, it comes with Jython. So most are not Python 3, okay? But this is kind of where scripts that you create would appear. If you want to take a look at one of these scripts, you can by like right-clicking and going to edit with basic editor. There is a plugin to use Eclipse. Last time I tried using it, it was super slow, but the last time was like 2 years ago. So my basic approach to creating scripts for Ghidra is usually I write them in another text editor in VS Code, and then I honestly like copy and paste them in here, or I'll use Ghidra's headless capability, just run them on the command line instead of dealing with necessarily this interface. So again, trying to be honest about some of the downsides here associated with Ghidra. I understand there's no syntax highlighting here, not very pretty to look at or work with on the right-hand side. Okay, this is just what you get, which is why I generally will use VS Code, right, a third-party editor, and then copy and paste into here. Or just, again, run on the command line using Ghidra's headless capability. Okay, so that's kind of a little bit about the scripting here. made a couple notes here. Let me check what else I wanted to cover.
And like in IDA, we had C++ plugins, and you also have IDC, and then obviously IDA Python, like you were talking about. Ghidra has Ghidrathon, and somebody even tried to do IDA Perl. I don't know what somebody was thinking on that one, but what is there? How is the plugin support? Can you write when you're writing extensions and such?
Yeah, the plugin support, I mean, it seems to be fine. You definitely should use Eclipse if you're going to kind of create plugins for IDA. I mean, in terms of, or for Ghidra rather, in terms of like the community, I mean, there are some plugins out there. There's more scripts than anything. But in terms of extensions and plugins, I've seen minimal, honestly. And it's certainly the community is not as vibrant as I would say it is for IDA. So that
a couple people were asking like, what are your top like must-have plugins? So you mentioned the
Find Crypt.
Yes, the Crypt one. Are there any others that you think like I can't live without these?
Honestly, I mean, my short answer is no. I mean, that's really the main one that I use. I mean, the other, and actually I meant to go over this earlier. The other, in terms of like pivots, this is just a script. It's not a plugin, but I just remembered it. Plugin wise, I mean, honestly, that's the main one that I use. Beyond that, it's kind of scripts, various scripts that I'll use from time to time for like, analyzing Golang malware, for example. There's some really good scripts that people have created to kind of match up the function names with the actual functions. And Ghidra's done a little better job over the versions of dealing with Golang as well. But one other script, right? It's not really a plugin, it's script that I want to mention is has to do with Kappa. Okay, so if you haven't heard of Kappa before, I think I had this open here somewhere. There we go. Right, so this is another Mandiant tool. So like I said, they've come up with some awesome stuff. Kappa is both a standalone tool as well as a Ghidra script, basically, that you can use in order to identify capabilities in files. And so capabilities aren't necessarily malicious, but they often can be, right? And so this is just kind of a sampling of some of the capabilities here. Let me just make this a little bigger, that it can identify associated with network communications or reading and writing files, registry accesses, and so on. You can see kind of a smattering of what that includes here. And so one thing that the Flare team did recently, and this was very recent, is to create basically some scripts that allow you to run Kappa within Ghidra, which is fantastic because Ghidra, what Kappa does is basically it can give you essentially the virtual offsets, the virtual addresses of where some of these capabilities might reside. So if it identifies that this sample creates a mutex or, interacts with files on disk or includes, the key scheduling algorithm for RC4, it'll provide you with the virtual addresses of where it believes either that basic block is or that function is. And now, since you can run that within Ghidra, you can jump straight there. So just to demonstrate this real quick, if I go back to the script manager here and I search for Kappa, these are the two scripts that Mandiant has released. They're basically the same thing, but one of them basically creates bookmarks, which is just another way to jump to different locations in the code. That's what this one does. And this one runs Kappa similar to its standalone tool. Basically, its output will be in the console window. So let me just show you what I mean. I'm going to use the second one. I'm going to double click on it. And down here, you'll see the scripting window pops up and it starts to run. Now, what it's asking you now for is a Kappa rules directory. So Kappa identification, the identification of capabilities is based on rule sets that are public. They're on GitHub. You can contribute to them. You can make your own, which is really nice. I think it's a really complementary to Yara, right? It doesn't replace Yara, but I do think that in many ways, writing Kappa rules is easier than writing Yara rules. And so definitely, if you haven't heard of Kappa, check it out. But what I'm going to do now is just on my box here to go to the location where I have the Kappa rules downloaded. That's right here. And you can see the various categories of these rules, right? So they are pretty encompassing. And again, this is just constantly being improved based on the community and the folks on the Flare team who contribute to this tool. I then choose a verbosity here, verbosity, however you pronounce that. I'm going to go with verbose here. Okay. And now the dragon's chomping away. Okay. And what you're seeing here at the bottom is that it's actually using those rules to identify some of these capabilities now. And again, the beauty here is once it's done, it not only tells me, hey, this thing, reads and writes files, includes encryption, etc., but it tells me where that actually happens. And the text that you'll see output here when this finishes is actually clickable, and you can use it to pivot into parts of the code. So for example, and I will zoom in here in just a moment. Lots of output here. So you can start to see, for example, right, that right here, it's detected this potential capability, encrypt data using AES, right? And it's got 3 matches. So these are virtual addresses that I can click on. So if I click on this one right here, double click on it, it actually takes me to that function that it thinks refers to AES encryption. So this is another beautiful way to kind of pivot into the code. And, you know, find crypt is great. I still use find crypt, and there are certain things it can find that rules have not yet been created for in Kappa. But Kappa is by far, you know, much more up to date, much more community driven, and so, you know, it continues to be a great way to pivot into code. And this works for, you know, executables, .exes, .net, ELF files, shellcode. It can really analyze all of it, and its rules are just constantly being worked on and improved. So really, really nice capability. Just another approach to kind of pivoting into code.
Yeah, for sure. Another great plugin, not probably commonly used with malware analysis, but is BinDiff, of course.
Oh yeah. So BinDiff, yeah. I mean, that's certainly another one that I've used from time to time. So BinExport, which of course is created by Google, right? It supports Ghidra. And so if you go to the project view, what you would have to do, and I already have BinExport installed for Ghidra. So thanks for reminding me of that. Really wasn't not on the top of my mind. If I right click on like this DLL right here, after I've analyzed, you got to analyze it first, of course. And then I go to export. You'll see there are various formats that I can export. And right here, I have the binary bin export, right? So this is where I would export each of the files, the database that BinDiff supports and creates. And then, of course, go ahead and load that into BinDiff. Okay, so that's another way to do it. I should mention, and I won't get in all the details here, although I did create a YouTube video on it. Actually, I think my most recent video is on BSIM. So Ghidra now supports diffing as well. I haven't done like a apples to apples comparison with BinDiff. I've done a little bit just here and there, one-offs, but it seems pretty compelling. And what's nice about the Ghidra supported BSIM databases is it basically gives you a view, and I can't pull it up here because I'd have to do a lot of setup, but it basically gives you a view that allows you to perform kind of like a comparison of one file to many other files. So with BinDiff, right, you can do kind of a one-to-one comparison. But with BSIM, which is, again, included in the most recent version of Ghidra 11, you can actually now do a comparison of like a function in one program with many functions in many programs. And that is real nice. So definitely encourage you to check that out if that's something you're interested in the context of Ghidra.
Our question just came up here. I'll put it up on the screen there so you can take a look.
Ooh, we have some similar scripts like Kappa for vulnerability analysis to find sinks. So since vulnerability analysis is not my area, I guess the truthful answer is I don't know. There could be, but I'm just not sure. But you know, you could use Kappa to create those same rules, right? Or rules that would target your particular use case, vulnerability analysis. But I'm not aware. I don't think Kappa rules currently support that. I could be wrong, but I don't think that's a category of Kappa rules currently.
Cool. I just put your channel at the bottom of the page as well. How often do you do videos, do you say?
Not as often as you, Steve. Definitely not as often as you. I'm trying to put them out every like 2 weeks, but I think that makes me due for one today. So I hope that hey. I have one that I need to edit. Yeah, maybe this counts, right? I have one that I need to edit, so I should have another one up soon. But I'm trying to get one up there every 2 or 3 weeks.
Cool. Do you know?
Yeah, always open to ideas.
So one plugin I really enjoyed, and I mentioned this. I had Hoshin Kodet on the other week, I think last week, and I was telling him about how I loved his MyNav plugin or script that he wrote. It was a plugin for IDA, but it's outdated now. It kind of looks like similar to BinNavi from Dynamics when that was around, which it's open source now. But the really cool thing about it was, say for example, you start up a program and you've got all that startup code, and you go and click on File, Open, get the prompt, but you don't actually open anything. You stop there. It basically stalks that, and then the second time you run it, it stalks it again, and then you actually click Open. And it takes all that startup code to get you to that point and removes it, just showing you the file parsing code. Do you know if there's any good plugin like that for Ghidra?
I have not heard of one. No, that does sound pretty cool. But no, I've never really, for my use case, haven't really looked at BinNavi very much. Because I think I'm sure there's some reverse engineers who do that maybe during malware analysis, but it hasn't generally been a part of my workflow to kind of take that approach. So I haven't heard of one for Ghidra like that. But yeah, it could exist. Just haven't heard about it myself. Trying to think if there's any other basics here that I may have missed.
Yeah, and if there's any other questions people have, please go ahead and post them up. There's a couple here on the right when you get a chance to take a look, Anuj, but no rush.
Oh, let me take a look here, because I think I full screened this, so that's probably why I haven't been seeing any. So I see a question here. What is the job market like for reverse engineering as compared to the rest of the cybersecurity industry? So yeah, kind of what I was getting at earlier is, reverse engineering is definitely a pretty niche skill set, right? While you might have a company that hires a team of incident responders, you very rarely have teams of reverse engineers. The exception being, I think, managed service providers, and also antivirus companies. So it is often limited to that, but that also makes, I guess, your target pretty obvious. So, if you're interested in getting into the field, I would suggest, pardon the pun, reverse engineering a job description, right? Take a look at the job description for a malware analysis role and see if you can do anything to kind of meet that criteria, even if it's over time. But it definitely is a kind of a niche skill set, right? And again, by that, I mean that you generally don't find teams, large volumes of reverse engineers that are part of one particular organization. They certainly support many, right? Like threat intelligence, right? That's every organization should be doing some form of threat intelligence. You need people on those teams who can understand malware, but you don't need like 15 people who can understand reverse engineering. Let's see here. What are the questions?
I think we're pretty caught up.
What's that?
I think we're pretty caught up, but if we missed anything, please poke them up.
Okay.
Or don't poke them up, put them up.
Yeah, I know. I think I saw a reference to an emulator somewhere here, and I think we probably don't have time to go over in great detail. But because Ghidra exists now, right? If you have an emulator framework installed within your Python environment, you can take advantage of that. And so, for example, I use Killing. Killing is a multi-platform, multi-architecture emulation framework, and emulators are certainly not an easy button. But when, kind of like what, Steve, you were asking about earlier, and I mentioned emulation, when you were dealing with a sufficiently complex algorithm that, you were trying to reverse and understand because you want to get at some underlying content, or maybe you're trying to create a script that will automatically decrypt or decode some next stage content. One approach is to kind of create a standalone Python script and code up and actually implement the algorithm. But as algorithms get more complicated, that can be challenging. And then we know that adversaries change algorithms. So now the script that you worked for days and weeks on to implement this algorithm no longer works. So for me, emulation, and for many others, emulation has been a solution to that, because it really uses the code against the malware author, right? Just like when you are debugging, if you want quick access to, for example, the strings that are being decoded at runtime, you might set a certain breakpoint at the end of a function and take a look at what strings it produces. Well, emulation allows you to automate that process without worrying about the underlying algorithm. And in fact, you can even emulate a Linux binary on a Windows system. And so there are lots of advantages to emulation, and you certainly can use Ghidra. I use Ghidra's headless analyzer to perform emulation tasks with Killing, and that is certainly possible with the magic of Ghidrathon. There's nothing native necessarily about Ghidra. I think it does have, so I should rephrase that. There is some emulation, I think, built into it. From a malware analysis perspective, I think these platforms that are all pretty much based on Unicorn are probably above and beyond what Ghidra has included with it.
Somebody mentioned, what was the name of that you just said? So I think you named something and they missed it. I don't know what that might be.
What I was referring to is Killing. So the Killing framework is the emulation framework that I have been using recently.
QILNG, great.
Yeah, and I actually did just maybe 3 weeks ago, I did like an hour-long session with John Hammond, and I talked about emulation, talked about Unicorn, and Killing as well. So if you want kind of a deep dive into that, check out that video.
Nice. Cool. Is there anything else you wanted to show us in Ghidra?
I I think that's most of it. I mean, unless people have questions, I mean, but like lots of little basic things that as I'm just kind of thinking about, like people might wonder, if you're looking at a call like create file, right? I know create file is not a very interesting one, but it's the one I just kind of thought of. The second argument here is going to be a reference to a symbolic constant, right? And this is a numerical representation. And, how do you convert this to the symbolic constant? So, in Ghidra, it's about right clicking and going to, let me zoom in on this, set equate. So if you do set equate, it'll provide you with a list. It's not always a short list. So you do have to kind of look up the API to understand what kind of the options are. But I think this one starts with generic, if I'm not wrong. Yeah, generic. So this is generic read. And so if I double click on that, converts that to the symbolic constant here. I mentioned a function ID, which is like the flirt of IDA. And if you want to explore, I mean, already it's got a function ID database it's using associated with a particular version of Visual Studio. But if you want to kind of explore that further, you can go to Tools, Function ID, and you can choose to kind of create your own function ID, right? Maybe you want to create your own database after you've heavily commented some code, or you're looking at some third-party crypto library, and you want to create a function database so that you can apply that to future analysis sessions. You can do that with function ID as well. And I think those are most of the basics around using Ghidra.
A few people asked about the debugger. Is that something you can just show real quick, or is it something you don't have set up right now?
Oh, I definitely don't have that set up.
Okay.
Yeah, I will not. Yeah, no, I definitely don't have that set up on this PM. And it's something. It's as a result of this stream, I think I'm motivated to really just make it work. I mean, when I told you I put like an hour of effort into it a few months ago, and I was just like, no, not doing it. But enough questions have been asked today that I'm motivated to maybe put together a video on it.
Nice. I mean, yeah, like same thing on IDA. Even though IDA has debuggers, I don't use them. I mean, I've used the WinDebug kind of IDA as the front end, WinDebug as the back end. But a lot of times when you're using IDA as a debugger, you're using these debugger stubs. Like you're using GDB server, for example, and you can't issue the commands like you normally would be able to. It's very limited. So I always just find myself using the native debuggers for the most part with some extensions.
Yeah, I mean, for me, especially focusing on Windows analysis, I really haven't found a need to move on from x64 debug. It's just been been great. And on that note, by the way, I think they actually do have some corporate sponsors now. But if you have a chance, and use x64 debug, this free tool, really supported by like one person primarily. Just definitely encourage people to kind of donate if you want that tool to continue to exist. But thankfully, I think recently they did get some corporate sponsors, which is great to see.
Yeah, I just had him on the other week, so it was nice to have him.
Oh, you did? Oh, you okay. Yeah. What's the author's name? I know his handle, but
I'm terrible with names. I really am, because I'm so used to seeing handles, so I never remember people's names anymore.
But yeah, definitely great tool. That's my go-to for debugging. So,
but there are a couple last questions popping up. We're going to wrap it up here in a moment, but yeah, if you want to hit those last questions, and then we'll call it a day.
Yeah, let me see here. Yeah, Ghidra Bridge. So Ghidra Bridge, I remember Ghidra Bridge. I don't know if it's supported anymore, but that was one way that I know, or one way that you could do Python 3 before Ghidrathon came out. So I didn't even recall that, but you might be right that it allowed you to set it up with GDB as well. So that's a good point. Books about emulation. Yeah, I don't know any books about any good books with emulation. I mean, I think it is relatively new. But again, you can check out that talk I did with John Hammond. I do try to go over a lot of the basics there. I mean, really, when you're talking about emulation, there's three most popular frameworks. At least I'm pretty sure these are the three most popular. Unicorn is like the foundation, right? Unicorn is the foundation for all of them, but it can only emulate instructions. So if you want something that's more file type aware, operating system aware, then you're going to have to go the route of either Mandy and Speakeasy, which I think is Windows only. Then you have Dumpulator, which is by the developer of x64 debug, and I think that's a Windows only as well. And then you have Killing, which is multi-platform, multi-architecture. It's kind of the reason I kind of chose that as my focus when I wanted to learn about emulation, because it can apply to different platforms and architectures. But there are some other really good videos out there about emulation as well. I think OA Labs has put some good ones up as well. So yeah, the only resource I'm aware of is basically on YouTube, right? Good videos on them.
Yeah, and like Luan said, Duncan Ogilvy is the name, and my brain is so misfiring right now. I haven't had him on yet. I've got him scheduled to come up. That's why I didn't remember his name. Duncan Ogilvy.
Okay.
Cool.
And hopefully, if I missed a question, just bring it up to the top. But I think I got most of them.
Yeah, and feel free to plug, put some questions in underneath the YouTube video once it's posted online. It should be there in a few minutes after this is done, and we'll take a look there and make sure we get them answered as well. But that being said, great to have you come on. Again, if you get an opportunity to take Anuj's course, it's a fantastic course, especially if you want to get more into this stuff for the most part, like the top of the pyramid, which is, of course, code analysis. Most people start out with malware behavioral analysis and such because it's a bit more intuitive, and you can get kind of. I guess that's one last question I'll ask you. Just put you on the spot. As far as setting up a reverse engineering lab, what do you think just the tips are with doing that to keep yourself safe and some of the minimum things that you need there? And then we will call it a day.
Yeah, I mean, the best resource I think for setting up a lab as quickly as possible is, and I keep mentioning them, right? Mandiant. They got the Flare VM, right? So if you have a Windows license, you can set up a virtual environment, and whether it's VirtualBox or VMware, their Flare VM script is probably the best free resource for just quickly getting just about every tool I have here, most of them. I'm not sure that it'll install like killing or anything, but most of the tools that I have here on my desktop are going to be part of that Flare VM. So, I mean, this is based on a VM we use for the SANS courses, but it's very, very similar tools, right? None of these are super secret tools. They're all available for free. So if you want to get started quickly, I would definitely just go to the Flare VM website. They got a good script to get you up and running quickly. Of course, on the Linux side of the house, we have Remnux, which was created and supported by Lenny Zeltser, co-author for 4610. So definitely even though it's Linux, right? And even if you're analyzing Windows malware, lots of really good tools on that distro that will help you analyze Windows samples as well, in addition to, of course, ELF binaries. So check those out too. But yeah, if I missed anything about Ghidra, throw it in the comments. I'll definitely check the comments. And if there's any gaps, happy to either comment or create additional videos to kind of explain things. But I hope that was kind of a good introduction to using Ghidra. I hope it wasn't too jarring for those of you who have not seen Ghidra before. Definitely encourage you to give it a try. As a reminder, right? These are all tools to accomplish a task, and there are many ways to do it. And there are many price points that people are willing to do it at. And so this is one to just at least be aware of and maybe even dig into if this is something you're kind of starting out with and want to dig deeper into.
Yeah, totally. Great points. And I put Anuj's course up here on the screen in case you want to check that out. I think you also do consulting, right?
Yeah, so I do some consulting on the side as well. Obviously focused on reverse engineering malware. So, happy to entertain any discussions about that too. The one thing I do want to mention about my course is it's been a while since I've taught an actual live course, whether it's in person or online. So I got my first, it's online, but I got my first live course coming up in June. And I'm going to teach for the first time live in person in probably a year and a half in August. So the one in June is going to be East Coast time. And then the one in August is going to be in Salt Lake City, Utah. So depending upon what time zone might work for you, or whether you want to do online versus in person, those are ones to consider as well if you want to actually meet me in person or actually see me live teaching the class.
Cool. Awesome. Well, again, thank you so much for coming on. Love to have you back again, maybe looking at some more specific, I don't know. I always want to see people do the encryption stuff because it's always a pain in my butt, and looking for tips and tricks there. So hopefully have you back on at some point. But again, thanks for coming on. Have a great weekend. Thank you, everyone else. And join us next week for, let me just check here. What is next week? Next week is the first. Oh, Kuba Gretzky. So next week we've got Kuba Gretzky coming on to look at multi-factor authentication bypass with Evil Jinx, or however you want to pronounce it. But he is going to be giving away a couple seats to his course. So that's an awesome opportunity to hopefully win a seat. Might be 3, might be 2. I'm not sure, but we'll see you next week. Otherwise, again, have a great weekend and see you next time.